right, a quick example of straightening nonlinear data that's not exponential in a relationship or logarithmic. This is exercise 23 from page 243. I'm going to apologize for not writing on the screen, but I'm having issues with the software. So here goes. All right, so the problem's about board feet and its relationship to the diameter. So here's the scatter plot. We can see there's a positive relationship, there's a strong relationship, but it's definitely not linear. There's a bend to it. So we want to get this thing straighter. You could start with maybe taking the logarithm of all of the board feet, just as an idea. If this was a quiz or this was an exercise, and you can kind of see where it gets you. So I'm just going to click on it, and then I'm just going to drag it over. And maybe it's a little bit straighter, but to me it seems like it's still bent, just kind of bent the other way. All right, so we'll go back to the original graph and see if we can get something that works a little bit better than taking the logarithms. So you can think about the actual definition of board feet. You could read the problem, kind of see what's going on in terms of how it is, or you could look at kind of what happens to this, pretend this is the log. If I increase or if I double the diameter. So I want to draw a picture of a log with a diameter that's twice as big, and then think about what's going to happen to the volume of it. Okay, so you can, go back to geometry class and decide that, hey, you know what, the volume's actually going to get bigger, by a factor of whatever the scale factor is squared. So when I double the diameter, then it's going to actually increase the volume by a factor of 4. And that's only because the logs are the same length. Or you could just start kind of trying things out. So maybe I decide that there is this relationship of y equals x squared. Right, so just to get an idea. So if y equals x squared, the inverse of squaring the x's would be to square root all the y's. So we can come back and say, okay, computer, take the square root of the response variable. And then we can take a look at the scatter plot and see what it looks like. Bingo, looks like that is one pretty darn straight line. So what that tells us is our good model, our transformed model would be like our predicted y's. So I'll go ahead and type it out. Our predicted board feet, but it's the square root of the board feet. So we have this predicted square root of board feet. Equals, we'll go ahead and get the equation since we're here. So we'll add the trend line real quick. X minus 4. All right, so it looks like predicted 4 feet equals the diameter as our x value minus 4. All right, it's predicted square root of board feet. So if we were going to go find it, say we said we wanted to know, well, what's the board feet when the diameter is 15? All right, we'd have predicted board feet, or predicted square root of board feet, 15 minus 4, which equals 11. And we have to remember that's the square root of the board feet. So the square root of some number is equal to 11. And then we have to think of, well, what's the inverse of square rooting it? So that would be the squaring of that. So our predicted board feet would equal 11 squared, right, which is equal to 121. And then, we come back over here and say, okay, well, here's 10, there's 12, so 11 is like right here. Oh, I guess, all right, so what is the issue going on here? Well, I think it kind of has to do with the fact that we have our transform data being displayed, if we're going to check it. So maybe we'll go back and look at the original data. And so now I have, okay, so here's 10, here's 12. So 11 is in between. Got to estimate a little bit. Still not 121, so maybe I have a mistake going on. And I'm going to try to find it real quick. Totally found it. Sorry, I am going to go ahead and record it just because I'm trying to get it out to you tonight and I'll be gone. Remember, our original diameter was 15. So I was looking at the wrong place, right? So here's 15. If we look at where the curve was, it would be about at 121. If we go back to the transform data and we go to 15, we should be getting something close to 11. I go up to the line, and that's pretty much at 11. So there it is, all right? So that's how we could transform some nonlinear data without logarithms. It's nice to understand the relationship between the variables, so knowing that there was this, kind of y equals x squared relationship going on is definitely helpful, but you can do a little trial and error to begin with. All right, so I hope this helps. Sorry, it's a pretty horrible video, and good luck on your quiz. Remember, math is cool, and so are you.